Today we will be going over the open specimen container training. Container is anything that can store samples or is just a physical location and that kind of stuff. So what we will be learning today is one introduction, creating containers, some actions that are related to container. Now these are coming in with latest versions of open specimen, container reports, and some additional features. Uh, so to get started, anything used to store specimen is called as container. So it can be liquid nitrogen tanks, -80 freezer, ambient storage, and any similar activities that you have. Uh, Basically, open specimen is flexible enough to be configured as per your local freezer model. So just to give you a random example, if you open any -80, -20 freezer which you have at your facility, whatever you see in front of you, that can be configured in open specimen. We'll see this in a bit more details. First part is about the user access. So which users are going to get access to specific containers? Now, this is the most complex part about how the containers are managed. So the first part is related to the sites. So every container belongs to a parent site, and as long as the parent site is associated with the user as well as it is associated with the collection protocol, then only the container will be visible to a specific user. Okay, and you can restrict it by site, by collection protocols, and also you can restrict it by specimen types. So now, what are the prerequisites to create containers? So there are a few prerequisites. The first one is you need to decide dimensions at each level. What does that really mean? So for example, I have a freezer. My freezer contains 4 racks. So my freezer dimensions will be 1 by 4. So I see 4 rows and 1 column when I open the freezer door. Now, if I open the individual rack, I can see 48 drawers stored inside. Uh, I can see 4 columns and 12 drawers are placed one above the other. So this way you need to decide the dimension of row versus column, and that has to be done on every level, hierarchical level of a container. So usually we start from freezer, shelf, rack, drawer, box, and box is usually the last one. But similarly for liquid nitrogen tanks, you can have tank, tower, drawer, boxes, and that kind of stuff. So all such things needs to be dimensions needs to be identified first. In case if you do not have any specific dimensions, for example, we are just using a bucket and all the specimens are just dumped into that. So in such cases, you can use dimensionless container. Bucket might not be the right word, but uh, many people use simple drawers to put it, something like cool boxes or some ice packs where they can just put the samples or hold the samples on some stands. So all such cases you can define the dimensions as 0 by 0. The next important in any questions still here, just feel free to stop me wherever you have any questions. The next part is deciding container naming convention. So basically, each container name has 3 types of names that are supported by OpenSpecimen. First one is a unique name, that is a mandatory. So usually what people do is they write down a complete hierarchical structure of a freezer. So just to give you one example, suppose you have a biomark freezer and it is first in the sequence. Then it has shelf 1, rack 1, box 1. So in similar fashion, you can create unique name, but it is not mandatory to follow this particular format. You can choose any format that you like. A few formats are supported by OpenSpecimen, but you always have a choice to override that and make any format that you want. Second type is a display title, so it is nothing but a caption. It doesn't have any uniqueness check or something. These are more like intuitive names or user friendly names for specific boxes, because many times, just to give you one example, if I have 20 boxes in rack 1 and my first 4 boxes are for serum, next 4 are for plasma, just looking at the box, it becomes these names, it becomes difficult. So you can always choose to add display title there. Also, if you are using any barcodes, then you can also make use of the barcode. Let me know if you have any questions. Next important prerequisite is the container restrictions. So what type of restrictions we have? So for first is by collection protocol or by specimen type. So many times what happens is we reserve certain freezers for certain study. For example, freezer A is reserved for breast cancer study. Now, many times what happens, the one study doesn't require a one complete freezer. So in such cases, they just reserve one or other racks. They also might have 4 or 5 different types of specimens, and they will say, okay, within freezer B, rack 1 will be reserved for plasma, rack 2 will be reserved for serum, rack 3 will be reserved for buffy coat. So all such restrictions can be decided, and you can mention any such restrictions. So restrictions are necessary for position auto-allocation to work. So in one of our last sessions during collection protocol training, I explained how container auto-allocation work. So in case if you have missed, please refer to that recording. Also, I will just try to brief how this position auto allocation works. So suppose within my freezer 2, my rack 1 and rack 3 are for plasma versus rack 2 is for serum. Then when system algorithm automatically suggest you positions, if it is a plasma sample, it will never suggest you position from the serum rack. So this is how the restrictions typically work, but you can go ahead and look at our documentation and the previous recording for more details. Any questions still here? Okay, so we just now we saw all the prerequisites. Just to re-summarize, we need to uh, know all the dimensions, naming convention of the container, what type of restrictions I want to add within a container or a freezer. Next is container types. Now this is one good feature that is supported by OpenSpecimen, and this is typically helpful for majority of the administrative users primarily. So container type acts as a template that will that will be used to create containers with a single click. So whenever, suppose in your regular day-to-day activities, you keep on adding few of the boxes. So let's say you have 9 by 9 box, and that you keep on adding every other day. So you can create a container type with the label of box 9 by 9, and with a single click you can keep on adding as many 9 by 9 type boxes as you want. So this is how the container type is used. More importantly, the entire hierarchical structure of the container, like freezer, shelf, rack, drawer, box, This entire structure can also be configured with the help of container types. I will show a small demo shortly, and it will be more clearer for everybody. This is what I just told. A container type is useful if you are creating the same type of container multiple times. Now I will show a small demo. Within demo, what we are going to see is this. This is one example -80 freezer. Just imagine you have a similar freezer in your lab. Now, if you open the door of the freezer, you see four shelves. So because of that, I have four rows and one column. Then when I open individual shelf, I can see place for five racks. Just to give you one example. That is why I can see five rows and one column. Then I have multiple drawers can be placed within a rack. So within each rack, I can store five drawers, and within each drawer, I can place a certain number of boxes. So this is one example that I will be demonstrating just now. So for this training purpose, I have created one freezer for you. So if you see this freezer, this is how it looks. So if I open the freezer, I will see four shelves. If I open any shelf, I see that okay, there are six racks that are placed. Under each rack, I see okay, there are five drawers, and under each drawer, I have five boxes. So this is the complete hierarchical structure that we have created. If you see the naming convention, then it is self-explanatory that TR is the site shortcode, so you can choose any shortcode that you want. But I'm configuring freezer one, shelf one, rack one, drawer one, and box four. So this is the naming convention that I have followed. If I go on the overview, this is where the most important things happen. So I will be able to see multiple things. So the first thing is the type. So what type of container I have used to create this box? That is -80 box. So this is a container type that I have configured for you. What is the unique name? This. So sometime back I explained that you can add a display name. So let's just try to add one display name over here just to see how it looks. Plasma box 1. I am updating. So now if you see in the hierarchical tree view, you will see the display name over here. If you select, you will see the unique name mentioned in the bracket. And the same thing will be available for all your end users when they are trying to store specimens like aliquots or derivatives or even while distributing. They will be able to see both these names so that it becomes very intuitive for them. And in case if you have a barcode, you can even search using the barcode. Any questions still here? Okay. So I will quickly go back to the container types. So I will just show you one or two and you can understand how it looks. So suppose I have a -80 freezer. Now within -80 freezer, this is the name format that I am using. My site code. So for training site, I just added a code as TR. So because of that, the TR is fetched by the system, followed by a dot and an F, followed by a unique identifier for that particular site. So that is one in this case. Uh, I saw four rows versus one column because of this dimension and position and labeling. Now what it does is I will show you, just give me a moment. I will show you going back to the container. So this position labeling and labeling scheme that defines how you want your boxes or your containers to be named. So currently the labeling scheme is rows and columns. So because of that, it will give you like A comma A, B comma B, that kind of values. And the labeling scheme that I have chosen is numbers by numbers. So because of that, it shows 1 comma 1, 2 comma 2. Let me show you within the freezer to make it see, if you see this shelf, you will see the positions are mentioned as 1 comma 1, 1 comma 2, 1 comma 3, and so on. If I go into overview, if I want to change it to just linear, so that means I just want to see 1 2 3 4 5. I updated, I came over here. Now you will see the labeling and position is changed like 1 2 3 4 5 6. If I want to make it alphanumeric, I can click on row columns. I can change the numbers to alphabet and numbers, and it will system will start showing it as you want. So whatever are your current naming conventions, that can be arranged using these two fields, that is position labeling and labeling scheme. Now, even the position assignment, many times what happens is people start the shelf one from bottom and then they fill up fill one by one and ultimately reach the top shelf. So in that case, you can make changes related to position assignments. So whatever are your real life use case, how your freezer looks in your current system, that can be configured over here. Here you can see the restrictions like collection protocol, specimen types, and that kind of stuff. If no restrictions are mentioned, all the collection protocols and all the specimen types will be available by default. Uh, I think there was some question coming in.
Yes, I have a question. Is there, it looks like every type of container has two different um, type of categories. Either everything is going to be linear or everything is going to be row and column. Is that correct?
That is for every container, yes.
Right. Okay. So even something like a drawer, which has, one level, but it goes deep several places, right? We would need to define rows and columns as different orientations. Does that make sense?
Yeah, it does. So basically, suppose you have this drawer. Within this individual drawer, let's just assume you have four layers where you can place boxes, right? So ultimately what you need to do is you need to change the change the dimensions for 5, and you will see that the 5 layers are present over here. So you can put the boxes wherever you want and block all the unwanted things, or remove the boxes from where you don't need. Does that help?
Yes, I understand. So yeah, so we'll need to just define our standard way of what we're going to call a row and a column, even as we're changing orientations a little bit through the drawers and the racks.
Yes. So basically anything that can be stored in a freezer, that has to be ideally mapped as a two-dimensional entity, so that it can be created within the system.
Okay.
And that way, basically what we are trying to do over here is we are trying to mimic how it looks visually in your system,
All right.
rather than making it technically correct that it is a three-dimensional view. And we are not trying to mimic the three-dimensional view.
Good. Thank you.
Yeah. So this is how we generally have one freezer. Now, similar to this freezer template, that is container type, I have mentioned that the freezer is going to hold the shelf. The shelf is going to hold the racks. So likewise, you can define any type of collection container. So when I say minus 80 shelf, then I have a minus 80 shelf type of container type already created. So because of that, you can use the naming formats. That is a mandatory field over here, as well as the dimensions. If you click on, if you check our help pages, then you will know which type of name formats are supported by the system, and what does each of the name format means. So all such information is also available on our wiki pages. I have also created a few videos around it, so that that will be helpful for you. So you can also go through them. The next part is creating containers using, now we know that container types are there, but how am I supposed to create a hierarchical container? So suppose I want to build this freezer. It has 4 shelves, and similarly 6 racks and that kind of stuff. So all I need to do is I need to select the freezer. Now, if I go to University of Arizona training, what I see, I have added a code of TR. So now let's see how it reflects for this particular uh, container type. So I am going to create a container. What I am going to select over here is container hierarchy. How many freezers I want to create? I can create two, I can create multiple. Currently, just for demo purpose, I will choose one. I have to define a site. This was one of the prerequisites also. So I am using University of Arizona training over here. And if you noticed the dimensions that I have mentioned within the container type, they are already populated over here. So no additional things I need to add. Here I can add multiple collection protocols or multiple specimen types as per my wish. So this is a multi-select drop downs, and whatever restrictions I want to add, I can add over here. So I can create this one. It will take a minute to create a complete hierarchical container. Yeah, so it created. So currently, I think for the training side, many people have tried it. So already 122 freezers are already created. So this is the 123rd freezer that got created, and you will see it has the similar kind of structure. 4 shelves. Each shelf has 6 racks. Each rack has multiple drawers. Each drawers has 6 boxes. So all such things are configured, and with a single click, I was able to create this entire freezer, this entire structure. So that is the use of this container types. So uh, just to give you a better idea, if I will start from home page so that it becomes easier for you. You can go via this widget, or you can navigate via this menu, and you can reach to containers. From the list view, if I want to create a specific container, what I need to do is create. Now I have 3 options. Suppose I want to create a single container, a single box. I can use this. If I want to create multiple boxes, I can use this. We just saw how the container hierarchy works. So this is the container hierarchy. All I need to do when I'm creating a single box, let's see one example. Let us try to add a box at this position. So I'm going to copy this parent name. Now what type I want? I want minus 80 box. So I'm just putting that value. I'm using uh, using a unique name that will be generated by the system if I am choosing a specific specimen type. Otherwise, I can choose a site where this box should belong. So my site will be training. Additionally, once I select that, I will be able to choose any parent container. So if I search over here, you will see all the freezers that belong to this parent site. So I'm just going to open one of them. And which one was that? F1, S1, R1, D1. So F1, S1, R1, and D1. Now you will see there are 20 free positions. So I can select any of this. So I'm just going to put it over here and click on done. So my parent container is defined, and rest of the things I am keeping as is for now. The most important thing is whether I want to store specimens or not. Because I am creating a box, I want to store specimen. If I was creating a drawer or a rack, I would have selected no. But currently I will just select yes, and I don't want to add any of the restrictions for now. So I will just click on create and see this one single box is created with just one click. So it is a very simple and straightforward process to add boxes on daily basis. If you want, you can choose any display name, change any type of labeling scheme. You can label it from bottom to up, left to right, right to left, anything that you want. Any questions on how the containers should be created? Now suppose I have multiple empty positions and I want to create multiple boxes in one go. What I'm going to do is I'm going to click on this place. I want to go for multiple containers. How many I'm going to create? 5. What I need is minus 80 drawer. I don't want it dimensionless. I want minus 80 boxes. Sorry, where is that? Minus 80 boxes. The rest of the things I'm keeping as is. If I click on next, see it will automatically pull up all the positions. The unique names will be also automatically generated. Currently, because I added a wrong name there, so it is not going to create one. But if I would have deleted the single container that I created, because of that the name is getting duplicated. So otherwise it would have created all 5 boxes. So this is the way you can create multiple containers. Any questions still here? Please feel free to stop me wherever required. So the multiple ways of to create container. This is what we just saw, using container types, single container, multiple container, the dimensionless container. Yes, this is one thing that I didn't show just now. So for example, if from within a container, I want to create one single box. I don't want to mention a type. I'm just putting the name as dimensionless. What I need to do is select the dimensionless radio button as yes. So earlier you might have seen that the rows, columns, position labeling, none of them now appears for a dimensionless container, and you can store the specimen and create. Which one is that? Just a moment. I think there was some issue with Yeah. So if you see, this dimensionless container is created. Now if I open this from here, you won't see any location map over here. So similar to box 7, where you have a limited number of positions. Now you won't be able to see any dimensions and any map over here. All you can do is click on the specimens tab. You can put as many specimens as you want within this container, and they will appear over here as a list. So this is typically useful when you have some temporary locations where you store specimens in cool boxes or ice packs, or just before processing you store them for as a master tube or pool tube. So in such cases, this kind of dimensionless containers are used widely. I just want to understand from you that how is the freezers maintained within Arizona? Is it a central facility, or are they managed by individual groups?
They're individual groups. The able collections will probably all be together though.
Okay, so all the because Able Collections is one of the largest group within the Arizona University, isn't it?
Hmm.
And so basically, how does they manage this container? So the lab staff will collect the specimens, process the specimens, and then they send the boxes to be stored within a central facility. How is it?
Brandon or Michael might be able to explain that. I think they do all of it themselves.
Okay, okay, no problem. So,
Yeah, for the most part.
mhm. So the next part is container actions in bulk. So these are a few new features coming with OpenSpecimen. So there are few actions that are now supported by the system. The question that I asked is typically for around this actions. So many times what happens is when you have a central facility, you temporarily remove the box from freezer and send it to central facility. Central facility can send it temporarily to a researcher and receive it back. uh, but they just need to document that yes, this box was moved out of the freezer. So in such cases, open specimen now supports these two actions, that is checkout and check-in. So checkout temporarily removes the container while keeping the location blocked. Check-in is just the returning of the checked out container. So whenever a box is checked out, all the actions associated with specimens within the box are still there. So you can process the specimen, you can distribute the specimen, you can put it back, you can move the specimen from one position to another. So all such actions are still available. It is just the box is not physically present within the container. So that is the only documentation purpose for which this checkout and check-in are introduced. The next part is archive. Many times what happens is when you have remote central facilities where containers are or the boxes are stored, the boxes are temporarily sent out to labs or the researchers, and the expectation is the boxes will be returned. But sometimes the boxes get damaged, all the specimens get utilized, and that kind of stuff. So in such cases, the central facilities needs to keep the needs to remove the containers from the system, but they need to keep a record that yes, there was one box with this name and that was present over here. So in such cases, you can archive a box and unarchive the box. And also the transfers. Now transfer is a pretty common thing, and you are well aware how the transfers work We'll see this in the system shortly. But this transfer is when the boxes are moved from one rack drawer to another place, same a different position within the same drawer, same rack. So anywhere, any movement of the box that needs to be tracked, that can be tracked with these kind of actions within OpenSpecimen. So let me go in OpenSpecimen. So so currently the Arizona system is not upgraded to the latest version, but I will show it on my demo site. So see, you will see a action button, something like this. Within the action button, you see all four actions like this. So just to give you one example, I'm just choosing one random box from the system. Now this box has many specimens that are present. If you see that this is fluid plasma, this pink, this purple thing is frozen tissue, this yellow thing is PBMC. So this kind of color coding can also be defined at based on specimen type. So now I want to check out this particular box. All I need to do is from the containers list view, click on checkout. I can add comma separated values. If I want to check out multiple boxes at one time, I can do that. So if I do this, I need to add, the name will appear over here. All I need to do is enter a reason, press checkout, and this way you will see that the logged in user, that is me, will be defaulted over here, and you can check out that particular box. Okay, so what type of restrictions are they? Let me choose some other freezer. Think a lot of freezers are with the similar name, so that is why I'm getting a bit confused. So please bear with me on this. Yeah, I don't know why it is giving this kind of error. I'm sorry, this is a bit embarrassing, but somehow the system is giving some kind of error just now. Some time back when I checked, it was working fine. So must be some kind of upgrade that has happened just recently. But just to give you one simple demo, See all this. This is our help pages. So here you will see all the container related actions, and you will also see certain videos, demo videos that I have configured. I have created for you. Hello. So I'm just trying to show you from video instead of from system. Say this. So I'm just using one container where you can see multiple type of specimens are already there. Now if I click on checkout, I will reach to this screen. I will add a comma separated values. After comma separated values, I can also use the barcodes. I will use the reasons. Similarly, multiple boxes can be checked out. I can add multiple reasons. So likewise, now when when the box is coming in, you will see that the box is checked out from the system. So now this particular box is you will see that a checked out event is added. It will be moved to the bottom. You will see a amber colored icon available for this particular box, so that the end users know that this box is checked out. And you will also see a status like this at the top of the container. And whenever you see the parent container like the drawer, then you will see the position as blocked, so that you know that these boxes are checked out from the system, and they are expected to come back. So this kind of container actions are supported by OpenSpecimen now. So similar to checkout check-in, you also have archive, unarchive, and transfer kind of actions. So all of these actions can be done in bulk now. Earlier, you have to go one by one for each container and perform these actions. So let us know if you have any workflow where you need to perform this kind of actions within the transfer. Whatever all you need to do is mention the destination for the container, and the box will be transferred. Whenever you transfer any container, all the specimens within the container will also receive one transfer event, so that you know that the specimens were moved, and you will be able to query how many times the containers and the specimens were moved. So there are four types of reports that we support. One is transfer, another is utilization, defragmentation, and empty position. So what does each report do? So I will just try to explain it a bit. So from the containers list view, you get this transfer report and utilization report. If you click on any of the transfer report, you can this is a parameterized report. You can choose for which freezer, for which collection protocols, for which collection container types, from at what dates, what intervals you are trying to move. So suppose I want it from for this year. Sorry, I want it for this year, but from 1st of January until today I want to fetch a report. I can click on generate, and a report will be generated. So this is how the report will be generated. Unfortunately, I don't have any headset for this report from this environment, but this is how you will. Let me try it from the test environment to give you a better idea. Let me open it in a different tool so that it is a bit more intuitive. Yeah, so this is how a transfer report can be exported. You will see who exported the report at what, and this will also give you timestamp. So what it typically has is name of the container, the barcode and display from where the container is moved. This is the freezer information from where this particular box one belongs. And this also have the container types that we just similar to what we just saw, minus 80 box, minus 10 box, 3-inch box, and that kind of stuff. And who did the transfer, what was the date, and also the reason. Now if you see, sorry, and also the reason. So whatever reason that I enter during the actions, that reason will be appearing over here. So as I showed some 4 or 5 different types of actions, so all such actions are also part of this report. So this is something from my previous demos. So checkout. So for checkout, you will see reason like this, checked out and whatever reason that I entered. Similarly for check-in, for archive, unarchive, and these are the reasons for the transfer. And after the from section, after the from section at the left, it will also give you where it was sent. So from and to, all this information is available. So this kind of transfer report is supported by OpenSpecimen. Similarly, you have utilization report, which will tell you how much space is present between uh, each of the container. So suppose I have a drawer where the dimensions are 5 by 4, so total 20. Total 20 positions are vacant, and amongst that 20, if I put 4 boxes, my utilization report will tell me, okay, 16 more slots are available for you. Now the defragmentation and empty position reports, they are useful for your day-to-day activities. I will tell you how. The defragmentation report is nothing but a report that is generated by system, which whenever you enter into any of the freezer, you have to click on export, and you will see that there is something called as defragment. So what this defragment does is it will give you a report that these positions are empty, and you can move certain specimens to the original position. So for example, many times what happens, you start filling one freezer, and now you are reached to box 1 of rack 4, but now few of the specimens from one of the previous boxes are distributed. Now you have to backfill the empty positions. So to backfill this empty position, this defragmentation report is used. What OpenSpecimen does is, OpenSpecimen gives you a suggestion, something like this. So this is my specimen label. This is the current location, and this is a suggested location where the uh, specimen can be moved. So if you see from this example, instead of shelf 5 rack 1, you also have a place in shelf 1 rack 2. So this way, the system will suggest all your end users how the specimens can be rearranged and freezers can be better organized. So for this purpose, this defragmentation report is used. Any question on these reports?
Yes,
And
I
the
have a
last
question. I'm sorry, I have a question about that. So if you generate
yeah.
that defrag type report, and then I assume there's a function that just says, you know, here's all, I'm moving all of these according to this report, and the system will move them all at one time because I'm going to compress this entire box, or I'm going to compress this entire shelf. Then how do we tell the system that I've followed the instructions of the report and I've rearranged them as suggested?
Okay, so that is a very good question, and I will be able to answer that. So this just see this defragmentation report. All I need to do is remove this top header rows, and this is nothing but the specimen import template. So all you need to do is go into OpenSpecimen or go into collection protocol. Choose any collection protocol and import use as a select record type as specimen, and choose the file and import it back. So all the specimens will be moved to the right position. Whatever compressed positions that you have mentioned within this file, specimens will be moved to the new location. Does that make sense?
I have another question.
Mm-hmm.
So do you know how it decides? Is it going to try and keep the same order that was there before the defragmentation, or is it going to try and keep samples from the same visit or donor or anything like that?
Or basically, how do we define the boundaries of the defrag report, basically?
So yeah, so basically that is a bit difficult to explain, but I will just try to explain that anyways. So any defragmentation report is specific to one specific freezer or the top level container. Now, suppose you have shelf 1 that is restricted for plasma, shelf 2 that is restricted for serum. Then all the defragmentation that is going to happen within serum sample, that will only look for available positions within shelf 2. It is not going to go into shelf 1. So if you have these restrictions for specimen types, collection protocols, if these positions are in place, then system will take care of rest of the things. Does that answer your question, or did I misread the question? Was there something else to it?
So I guess I'm assuming that the defragmentation, let's say if I had sample 1, 2, 3, 4, and then 2 and 3 were taken out, that it would just simply be compressing. So then you would have 1 and 4 would be the suggested defragmentation result.
Yeah. So that is a valid question, and additionally, suppose it might happen that the defragmentation report says move sample 1 to the box 1 and move sample 2 to box 2. So if
Yeah.
you want to prevent that, while generating the defragmentation report, you get this kind of pop-up. It will ask you, do you want aliquots of the same specimen, that is same parent's primary specimen, to be moved together? So all the aliquots like 1, 2, 3, 4 of one whole blood can be kept together.
Okay, and then I'm assuming so that's good because then those can be kept together. But then I find that the order that we originally put them into the boxes, we usually want to preserve that because they'll usually be utilized together. So I just wanted to make sure that it's just doing a simple, like, besides the keeping aliquots from the same specimen together, that it's doing just a simple compression so that I can keep my, my first visits together and my visits that were more recent together and things like that.
Yeah, the way we collapse things now, we think you could think of it more as like everything stays in order and we just collapse it straight without any reordering. It's just collapsing the absent values.
Okay, okay, okay. So basically, if you give it a try, it might also, I mean, the original sequence of the identifier is also mentioned, I mean, maintained. As long as you have empty positions, it will just start backfilling. It won't pull something like the last in sample will be moved to the first available positions. It won't be doing that. Does that make sense?
Yeah, we'll have to try it out and see
Yeah.
more details. Yeah.
Even to be frank, I'm not really 100% sure what your use case is and how that needs to be done. But one simple tip over there is whatever your destination locations are, you can also change it manually if you want. So system is going to preserve all the sequences and all. Even they are going to put all the specimens from the same primary specimens together. But in case if you still think, oh no, this doesn't look right, I need to change these positions, then even that can be uh, achieved via this simple Excel.
Okay, thank you.
But I think just give it a try as a real life use case and let us know if you face any issues so that we can help you more on this part. All right. Any other questions related to this? So apart from that, we have some other additional features like container maintenance tasks. So what it really is many times uh, people say my freezer needs a cleanup, my freezer needs to be defrosted. Sometimes freezer is deliberately turned off and all the specimens or all the containers are moved to a different position. So in all such cases, whatever are the periodic activity or pre-planned periodic activities, open specimen gives you an option to create maintenance tasks. So you can also assign these tasks to specific users. So for and the system will also send you reminder emails that uh, Brandon needs to do freezer maintenance tasks on this and this date between this and this time, and he will be notified one day earlier or something like that. So all such kind of container maintenance tasks can be configured with the system. Do you have any uh, uh, such kind of maintenance tasks happening in your day-to-day activities as a periodic activity, or that is on need basis?
Yes, we do.
Okay, so in that case, you can configure multiple container maintenance tasks. So if you go within the open specimen and select any container, at the top level container, you will see a maintenance activity over here. You can add the scheduled activities, name, task, start date, what interval, days, weeks, months, how many days before you want to remind, who are the users, and that kind of stuff. So you can add all such scheduled activities from this place, and you can also you will also need to run the job that will automatically send reminders for these activities. So we have a detailed wiki page that will come very handy for this. But if you want, just let us know for one or two freezers so that we can configure that for you, and you can configure it for rest of the freezers on your own.
And is there an indicator as to whether the user completed that task?
So basically, it is the activity log, and whenever user completes that particular activity, he can document as a comment or something.
Okay, thank you.
So within the activities log, you can simply say that I have this activity that was scheduled, that was performed by me, this was the date, this much time I took, what type of activity. So whatever activities you define in the first tab, that will appear in this drop down. So you can choose that activities, who performed, which date, what time, comments, and that kind of stuff. Even if it is an ad hoc activity, you can still choose a ad hoc and document everything. So this is pretty much that we had, and the last part is the bulk operations. So mostly the bulk operations that we have already seen related to actions, but apart from that, OpenSpecimen also helps you do many things via CSV bulk import. So we have already seen the uh, defragmentation report, but in similar way you also get empty position report, you also get a map of the entire freezer, uh, the entire map of the freezer, the utilization within the freezer. So all such things can be exported in CSV format. You can also select any container and export. So all the names, positions, schema, everything will be exported for that particular freezer. And you can also update or create many containers using the CSV bulk import. It is very similar to how we import specimens or participants via CSV. Similarly, you can also do bulk operations on the containers. Of course, that is not the topic of today's discussion, but all such activities are supported by the system. Now, the primary part that I wanted to cover is already I have already covered it, but now I want to understand from all of you that what type of actions or activities related to containers are performed on regular basis by Arizona University. Is it like uh, sending to certain central facility, or transferring boxes? Are all such activities monitored and documented?
Um, so there might be a couple cases like that. So one might be like we might have a pickup box that is sent out weekly on a particular day. And another type of thing would be like defrosting a freezer. So those are two examples of regular things.
Okay, so that can be managed. And additionally, are there any specific workflows around the containers, like uh, uh, we share this place or this space for able protocol one, this is for GABS protocol, this is for some other protocol. I am going to
Yeah,
rent out this particular racks for outside studies. So do you also perform that kind of activities?
yeah. So there within like a -80, we would end up restricting. We wouldn't put doer samples in there, and doer samples would go in the doer. So like PBMCs would go in the doer. And then there was something else. Oh yeah. So we'll assign a range of boxes to a particular studies to be filled.
Okay, and to create new boxes or to create new drawers and the overall container structure, who does that? Is it the end users or the administrators? Who is it?
The administrators.
Okay, okay. So administrators will have the access for everything. Okay.
Yeah, and I actually did have a question related to this. So because we are constantly updating which collections are assigned to which boxes,
Mhm.
do we have a way to bulk update those assignments? So like if I now want this box to be assigned to this protocol and that's changing constantly and I don't want it to click into each and every box.
Yeah, that is easily doable. So you can select the box, export. It will be exported as a zip file. You can open the zip file, and if you see here, you will see that. So allowed collection protocol. This is the field where you can define the studies. So whatever are the CP short titles defined in OpenSpecimen, the collection protocol short titles. So whatever you see in the short title column, that can be added over here. So you can do that for all the boxes, all the drawers, racks, at any level of the freezer, and you can do it for multiple things. And whenever you are done editing that, suppose you can do that for collection protocol, you can do that for specimen type, you can do that for distributions and all such things. Once you are done updating, all you need to do is come back to OpenSpecimen, go to containers, and during import, instead of create, just use update. So based on the unique names of the containers, this name, based on this name of the container, all the information related to that box or that container will be updated. So you can change specimen type, collection protocol, dimensions, labeling and positioning, all such information.
Yeah, this is a very powerful feature, and I think obviously we're going to have to, Brandon, restrict this very carefully to who has who has access and power to make those types of changes.
Yeah, and it also does do validation. So if we mess something up, it's gonna check it and give us a warning.
Yeah.
Yeah. And more importantly, if user doesn't have access to any specific container, then he won't be able to export it also. So it is not that I don't have access to TR F1 freezer and I am able to export and update it via bulk import. That is not going to happen. Does that make sense?
Yes.
Any other question? So I also want to take this as an opportunity to understand in your current system, that is tissue metrics, what type of limitations have you faced related to containers? Are there any specific common problems that you are facing and that you expect OpenSpecimen to solve?
Well, being able to reorder and collapse and compress things is certainly going to, looks like it's going to be much more available to us here in OpenSpecimen. That feature will be nice. I think we can adapt the functionality that we've seen into a way that's useful for us. We will be able to, as we can say, as we're scheduling periodic freezer defrost and things like that, to be able to move en masse, you know, the entire shelf to backup units and things like that. That will be helpful. But
Okay.
and I think we've just discussed in detail the most common occurrence that happens to us when, oh, we're running out of room in shelf 1 for project X, and we need to make sure we've got more boxes available. We end up making more of those changes than we think, because when we plan out a project, we're never quite sure how much we're going to get, and then sometimes we'll allocate, you know, we're going to have, you know, 50 boxes for this, and we end up filling up those 50 boxes in 3 months, and we need another 100 of already. You know, we have things like this, so we're reallocating and reapportioning spaces with more frequency than we expect occasionally. So I think we've seen some of the power that those are the things that we're going to have to utilize. But like I say, when going through and changing the definitions in that spreadsheet, that's an easy way to do it, but I'm afraid it might be an easy way to mess it up if we're not careful. So that's where we're going to have to spend a lot of time learning that system in great detail.
Yeah, and more importantly, once you start utilizing the system, you will realize that it is more simpler than it appears in the first look, but it is much more simpler, as well as much more robust, so that majority of the validations, many of the what you can say, specific rules and flexibility offered by the system, that is going to help you a lot throughout your process of learning, as well as utilizing OpenSpecimen going forward. But coming back to one point that you made, utilization report is our new utilization report is one feature that will help you achieve this kind of activities. So what it really is I will just try to export one utilization report so that it becomes a bit clearer for you. So let's assume you have uh, one rack, and within the rack you have multiple boxes, and rack 2 is uh, given for what you can say, given for one collection protocol, let's say GABS. Now if you check over here, you will see how many free position amongst each of these boxes and each of these containers have. So currently if you check the row number 17, so that is the rack 2, and you will see the just below rack 2 all the boxes within rack 2, and you can also see how many open positions are there or free positions are there for each of these. So you still have an option to place one box within the available box. These many positions are available. So if you do a bit of a math, then you will be able to get a better idea at what frequency and at what time you need to add more boxes, you need to make space at which boxes, and that kind of stuff. This is called as utilization report. So similar to your transfer report, You can also restrict it for specific collection protocol, specific type of specimens, and that kind of added, what you can say, uh, added parameters. So if you export it from here, you can choose from which freezer I want to see how much utilization is done, for which collection protocols, and for which types of containers. So all such things can be identified from this report. Suppose you only want to check for racks, then you can, all you need to do is select the type as racks, and it will give you report for only racks. So this kind of reports are also there within the system. So in case if you have any such specific questions or any such other use cases, you can feel free to ask now. But even if you think about it a bit later and you come up with some questions, feel free to ask. Right? Any other question? Any other challenge that you faced until now utilizing containers via tissue metrics?
Just mainly the speed. Every step takes a long time to process in tissue metrics, and OpenSpecimen is a lot faster. So I'm looking forward to that.
Okay, okay, that is good to know. And whenever in case you feel that there are any performance related issues, just let us know, and we'll try to fix it on priority, because one of the key features of OpenSpecimen is the speed and lightweight. Being a lightweight web application, that is one of the most important feedbacks that we look from the end users.